Hello, everybody. Good morning. Good morning to those present here in the room, and of course to those joining us online as well. Welcome to Space Resources Week 2023. It's so lovely to see faces coming back year after year from all over the world, and new partnerships being forged in the making through not such a long period of time. So as anybody knows who's been a regular here at Space Resources Week, last year 300 people on site in Luxembourg and close to 700 people online. This year we're looking at up to about or more than 450 people on site and about 900 people following the live stream. During this year's event, we're going to focus on synergies required for the development of an inclusive space resources utilization ecosystem, and as always, on ways of accelerating the use of space for the benefit of humankind. We have a packed agenda with wonderful speakers, talks on new technologies, business models, concrete next steps from inspiring scientists, economists, lawyers, and business professionals and entrepreneurs. The event is focused and continues to focus on drawing a clear path between key actors based on an international approach aimed at sustained and sustainable activities beyond Earth. So with that, please give us a warm welcome for our Minister of the Economy, Franz Fayot.
Good morning, ladies and gentlemen. As always, it's a pleasure to be here at the Space Resources Week. Last year I was in a different room. The setup was a little bit more poppy, I would say, with someone singing a song before it all started. And so this time it's a little bit more sober, but still I'm very excited to be here. And Lisa was saying it, the audience is fantastic. I think the turnout is as big as it has never been before. And so I think this really shows how big and how important this event has grown. It really has become the event of reference for the space resources utilization and the whole community that has built around this and has grown over the last years. This event is also a fantastic example of a fruitful cooperation, and we all know in this room that space is all about cooperation and collaboration. This event is organized by the European Space Resources Innovation Center, the ESRIC, the Luxembourg Space Agency, and the Luxembourg Institute of Science and Technology, and of course also the European Space Agency, which is represented here at this event by its ambassador, the astronaut Matthias Maurer, our friend from the Saarland, who is a German astronaut, but whom we here in Luxembourg also consider a little bit to be Luxembourger, and very proud of that. So, as I was saying, this event is recognized worldwide as a really, I think, the prime event in and around space resources. This year is also a special year because it is the 5th anniversary of the space resources, of rather the Luxembourg Space Agency, which has also established itself as the actor who is driving the development of the space economy here in Luxembourg. The Luxembourg Space Agency, of course, does not, as other space agencies, organize launch missions or is directly conducting research, but it is very much, as Luxembourg itself is, I think, I would say, a connector. It is connecting actors it is connecting with other space agencies throughout the world, but it is also connecting the private sector with research, and it is connecting all these people that are, I think, a lot of whom are in the room today, that are building the space industry. And it is truly, I think, the animator of fostering collaboration between the key players in the space agency. And over the past 5 years, the agency has been doing that very successfully indeed. Over the next 5 years, we will continue our efforts to develop the Luxembourg space sector as a vector of diversification of the Luxembourg economy, but also as a major contributor to the sustainability of activities on Earth, and by favoring a responsible approach to activities in space. All of you know that when we started out 6-7 years ago with our space law, which was enacted in 2017, I was the rapporteur in Parliament, I should know, but I think it was 2017. We were talking a lot about space mining back then. The focus was on space mining, but I think we have all understood in the meantime that the space economy and space resources is so much more than space mining. It is an instrument to solve our problems on Earth. Only thinking about climate change, space has fantastic solutions in that respect, but it is also a challenge to ensure that we have a sustainable space economy in outer space. Space traffic management, debris management are just but one application in that respect. And then, of course, it is also about sustainability and inclusion of the whole ecosystem. We need to make sure, as a small country, that the space economy is not only for the big countries and the big actors, but also for smaller and medium countries, such as Luxembourg, and we are very committed to that. I would only mention the program we are running with COPUOS in making sure that smaller developing countries also get their own space legislation. This is something we have started a few years ago and which we are, of course, going to continue. I would also like to say that as a Minister for Development Cooperation, I'm a strong believer that space can also be a formidable instrument for the development cooperation, helping developing countries improve their agriculture, in managing droughts, in managing floods, and of course also in managing climate change, which is so much worse in the developing countries in what we like to call the global south than it is even here in the developed world. So a lot of applications, and we have really I think last year presented this new strategy of the Luxembourg space sector, which is all about sustainability, and this will of course continue in the coming years. Now you will hear a lot over the next days about ESRIC, about also the space resources challenge that ESRIC is running with ESA, about the ESRIC startup support program, about also the idea of creating a ground-based pilot plant, all of subjects that will be presented to you by speakers that are far more knowledgeable on this than myself, so I will not dwell on that. I will spare you that, but just to say that you have a fantastic and very exciting program coming up over the next days. This year's topic, as Lisa already indicated is about putting the focus on the synergies required for the development of an inclusive space resources utilization ecosystem, as well as on ways of accelerating the use of space for the benefit of humankind. Synergies, yet another, I think, example of collaboration, of cooperation. Once again, very much core to what we have been doing for a long time in this area. I would also like to say that I'm very excited that we are going to sign a memorandum of understanding between ESRIC and the Korean Institute of Geoscience and Mineral Resources, the KIGAM. This is also the result of an international cooperation and of a mission, economic mission, that I did with, of course, my team in November last year in Korea. And this is a very first and very concrete, and I would say very rapid result of this mission. And I'm very, very excited that we have been able to get this finalized in such a short period of time. I would like to stop here. Thank you for your attention. Thank you for being there, and wish you all a fantastic Space Resources Week. Thank you very much.
Thank you so much, Minister, and it's wonderful to have your presence here year on year as well. Now, our next talk is going to be online. It's a pre-recorded message. It's from Bill Nelson, NASA Administrator.
Hey, everybody. On behalf of NASA, our entire NASA team, as well as our Deputy Administrator, Pam Melroy, it's an honor for me to come and speak to you at this Space Resources Week. Thanks to the Luxembourg Space Agency, to ESA, to the European Space Resources Innovation Center, and to the Luxembourg Institute of Science and Technology. Thank you for making this conference possible. I also want to thank Minister of Economy Fayot for inviting me to join you today. We are aiming to push the limits on what we know to be possible at NASA. We make the impossible possible. We extend our human reach throughout the cosmos. A couple of weeks ago, we named the Artemis crew that's going to venture to the moon for the first time in a half century. Ladies and gentlemen, your Artemis II crew. It will have an international astronaut for the first time to go to the moon. NASA and our partners are creating the future of cutting-edge technology. Fire. And this time we are going to the moon to learn to live, to invent, to create, and then to go to Mars and beyond, and we are going together. As more nations are active in space, NASA is proud to partner with other nations and Luxembourg because it will drive a space economy that will benefit all of humankind.
Thank you so much to Bill Nelson there. I was actually very impressed by his very slow speaking in English, and I was thinking for anybody who's not a native speaker of English, you could learn a lot from that too, apart from the science, of course. Now, our next message is also pre-recorded, but this is because these people are, of course, so very, very busy, and it's from Josef Aschbacher, who is the Director General of ESA.
Dear Minister Franz Fayot, dear distinguished guests, dear participants, I very much regret that I cannot be with you today to open this edition of the European Space Resources Week like last year, where I had the pleasure of being with you. Let me start by thanking the European Space Resources Innovation Center that together with the Luxembourg Space Agency, LSA, and the Luxembourg Institute for Science and Technology LIST are the organizers of this event. It is always with great interest that I'm following Luxembourg space activities and their forward-looking approach driven by commercialization. As you know, commercialization of space activities is one of my priorities for ESA and one of the challenges in Europe if we want to accelerate the utilization of our know-how and space capabilities for the benefit of our societies at large. The European Space Resources Week is one-of-a-kind event in Europe and beyond, as it represents a unique forum where to further the understanding and cooperation about one of the frontiers of space cooperation and why we do it. As you may have seen already, last month we presented to the ESA Council and release to the public the final report of the high-level advisory group on human and robotic exploration for Europe, called the HLAG report. This group of European distinguished figures, most of whom do not come from the space sector, have worked together over 6 months and have come to the conclusion that Europe should engage in a bold and daring exploration program. In order to do so, we should act visionary, should act differently, and above all, we should act now. The HLAG members call for Europe to gain autonomy in the field of space exploration for the benefits of Europe and also to reinforce the cooperation endeavors in which we take part. This is, of course, only one step of a long journey, but one step in one direction that will take us to a space summit in November 2023 in Sevilla, before continuing other decision points. ESA has already initiated a technical reflection on the possible response to the HLAG recommendations, which we are discussing with our member states right now. We believe that Europe has the potential, the ingenuity, and the ability to gain a place in future space exploration endeavors more adequate to the size of the economy, its global role, and the quality of its talents. In this context, as we prepare to go further to more distant destinations or plan to establish a permanent presence on the moon, space resources represents both a driver for the economic value in a legal framework and an enabler, as they will enhance the ability to reduce the dependency from supplies from Earth. We know the number of legal, technical, and scientific questions still to be answered to deploy the full potential of space resources. Let me just mention the strategic importance of the research being conducted on the extraction of oxygen from the moon regolith. Mindful of the need to find a suitable and shared legal framework, space resources are also a domain where private and public players can work hand in hand to achieve more and more rapidly through a more commercial-minded approach and with the aim of opening up new markets. This is the importance and interest of an event like the European Space Resources Week, and I would like to praise the cooperation between ESA and the European Space Resources Innovation Center based here in Luxembourg. Let me conclude by praising the cooperation with the Japanese Luxembourgish company iSpace, whose mission 1 of their Hakuto R lunar program is on its way to the moon surface. I like to remember that iSpace established itself in Luxembourg thanks to the Space Resources Initiative launched in 2016, and that the mission itself is an example of a cooperation between the so-called new space and the established space agencies. Under these good auspices, I am convinced that the European Space Resources Week will result in fruitful discussions and will end with a great success. Thank you.
Thank you so much to Josef Aschbacher there. Now, when the lights went up, I noticed there's a number of our in-house visitors here who are standing at the back. Plenty of seats available on this side of the room. You're very welcome to stand if you want, but there are many, many seats available if you so wish to sit down as well, because we have many more talks before the first break. And our first talk in the room is going to be from Bernhard Hufenbach, who is the head of ESA's Strategic Planning and Outreach Office for Space Exploration. So please give him a very warm welcome.
Good morning. If I could please have my slides on the projector. I get started. For ESA, space resources is a relatively young field. ESA only started in 2019, which is 4 years ago, to invest significant resources in advancing the field of space resources. And it was in 2019 that we published our first strategy for space resources, something we had never done before. And we established a cooperation agreement with the Grand Duchy of Luxembourg to establish ESRIC. So that was the first step for us to start to enter into this domain. And the last 4 years, we achieved significant progress. We have mapped technology maps and started some R&D activities. We built a fantastic research capability here at ESRIC, and we will hear a lot about this in the next 3 days. We are formulating missions for prospecting resources, demonstrating technologies. We are advancing our work on a legal framework, hopefully, among the different nations, which is a very important enabler. We are studying the first use cases, and we're even incubating the first startups here at ESRIC. So a lot is happening in 4 years, but it's not enough. It's not enough because if we really want in Europe to play a meaningful role in the field of space resources, we need to accelerate. And that's the topic of this conference, and that's the topic of this speech. How can we accelerate the field of space resources? This is a very busy slide, but it really shows on a single slide the context we are in Europe. This is a summary of the European Space Exploration Program as it exists today, and shows also the plan for the next 10 years. So what does it show? Our main activity in low Earth orbit is still about operating and using the space station with our international partners. On Moon, we are providing the service module for the NASA crew transportation system, Orion. And we are also providing key pieces for the first lunar outpost in the lunar vicinity, the so-called Gateway. We're developing the Argonaut, a heavy logistic lander, which can deliver up to 1.5 tons to the lunar surface. And we're even developing the first commercial communication navigation services to become operational by the end of this decade, and it's called Moonlight. So we lighten the moon. On Mars, we will deliver the Rosalind Franklin mission to look for signs of life before the end of this decade. And again, in cooperation with NASA, we hopefully return the first samples for Mars. So altogether, it's a very exciting program because we send regularly astronauts to low Earth orbit. Hopefully, we can send first the European astronaut to the Lunar Gateway and later to the surface. And we really deliver groundbreaking science in all those destinations. It's a good program, but you don't see space resources yet. So why are we investing in space resources? We invest in space resources because space resources are an enabler, a new capability for implementing space exploration in a much more sustainable manner. Through space exploration, we develop new means to build habitats on the Moon and Mars. We will find more efficient ways to transport goods and humans between all those destinations. And we can also more cost-effectively develop and operate infrastructures in this area for science and applications. So in order to do that, in order to find this transition to more sustainable exploration, we need to follow a radically different approach than what we're doing today in the way ESA formulates, defines, and delivers space exploration missions. The level of investment, the level of innovation, and the speed we need to develop this field requires a fully commercial approach. And what ESA really aims to do, also maybe we're not saying it so clearly today, but what we really want to do is to create an in-space economy and enable new markets by exploring and exploiting space resources. You find just some examples here. Future spaceships, like some which may launch very soon, will increasingly use refueling. In some cases, it may be better to use fuel produced off Earth rather than fuel produced on Earth to make it more cost efficient. If we ever really seriously want to sustain human presence on Moon and Mars, we need to use local resources to make it affordable. If we want to sustain human operation, we need to grow plants. Again, we need to use local resources to grow plants on Moon and Mars. If we want to build the significant energy infrastructures we need to sustain massive scientific and human operations, we can use local resources to build these infrastructures. And the new emerging field of in-space manufacturing will only fully develop if we embrace the idea of making use of local resources. So there's huge potential for the future. And ESA, really what we're trying to do with ESRIC in our program is to act as a facilitator to enable this market to emerge. And there are lots of things we could do, but today I think for the foreseeable future we focus on 3 lines of actions. You will hear a lot today and tomorrow about the first successful implementation of a space resource challenge. Now we want to see how, based on success, we can transform this challenge into a challenge which will enable us to create those markets. That's one element. We're building this fantastic research community at ESRIC, but we want to make it open to the community. We want to foster not just institutional-driven research, we want to see more private, commercial-driven research. We want this to become even more important than institutional-driven research. Hence, we want to open this facility to the community. To do that, we will establish at ESRIC a Space Resource Accelerator, which will co-fund research projects proposed by industry to us, rather than defined by us. And also, we want to change our procurement model. We are currently reflecting about how we can procure services rather than missions. That could be very relevant for space exploration. We're already doing it. Moonlight is a lunar ComNav service we procure. We're not procuring spacecraft, we procure the service. Of obvious first case for space resources is the procurement of data. Data to improve lunar landings, lunar mobility, but also data for improving our understanding of the resource potential on the moon. We will hear a lot about these ground-based pilot plant we built here at ESRIC, which in combination with access to a dusty thermal vacuum chamber really provides a unique research capability in Europe. And we want to open this to the community. This facility can address a range of research questions, from scalability issues to long-term operation. So how do we want to open it? We want to define it as an open architecture as far as possible, which enables to test different technology function, a different technology solution for different functions. And in order to do that properly, we will consult the community on how we can best develop an open architecture and what are your high-level requirements. So we can engage in defining the future of this facility here at ESRIC. If you want to know more about it, then join our session at 2:10 in the same room, where we tell you about how you can engage and what our objectives are. I talked about the Space Resource Challenge, and here you see the implementation of the first challenge. You see the participants. We really need to make optimum use of the idea of innovation-driven challenges. NADA doing that since a long time. They are private challenges. We have done it for the first time in the last 2 or 3 years. But now we want to transform this. We want to transform it into a challenge which is aimed at creating markets rather than just to demonstrate technologies. We want to develop a 10-year roadmap how we can use this challenge. And factors to consider are, can we go from a ground-based to space-based challenge? Can we increase the prize money? Maybe even using private sector prices, not only institutional prices. And can we enlarge the international reach of this challenge, not just making a European, but an international challenge? So again, this is something you don't do alone. We will issue a call for ideas, where we ask you about ideas, how can we make optimum use of this challenge? And the winners of the first challenge and the approach for the future will be discussed also at 4:45 in the same room. And then finally, there's so many opportunities at ESA where you can propose to ESA industry-driven proposal. ESA is changing. Our DG mentioned it. We embrace commercialization. We embrace the idea that ESA becomes a facilitator of industry-initiated activities. We have a call for commercial partnership, which enables you to come with an early idea for service and product, and we work with you to help you the best way to benefit from the ESA ecosystem, which can support you in advancing your business case. We have something which is called the CASE Open Call for Proposals, where if you have an idea for a service in space, you come with an anchor customer, which is not ESA, you get funding support to put this service in place. We have now a commercialization program, the scale-up program in ESA. They will soon issue a call which supports the transactions between the service provider and the customer once the technology is ready, allowing you to reduce the cost and become more competitive. We will soon issue an ITT, which is called Lunar Economy Applications, where we study and co-fund feasibility studies on future application enabled on the moon by the various infrastructures we put in place. Hence, there's a lot. You'll find all those calls in a single web page. You find the link. It's called the BSGN ESA INT web page. If you want to have more information, you're also welcome to visit our ESA booth. I think the message is very simple. If we want to succeed in this initiative, we need to grow and diversify the community, and the increasing number of participants in this event is a great sign that there's interest, and the age is even better, because there's a lot of potential to grow in future. We need more funding. We need more institutional funding, but we need more private sector funding. So the interesting question is, how can we mobilize private investment in advancing the topic of space exploration, utilization of resources? And we need to demonstrate use cases. As of today, we have not demonstrated a single use case in space. We need to make that happen to reach a different level of investment in future. So in short, I think your engagement is key. Thanks a lot for the attention. And I'd like to thank Victoria. She's sitting in the back and has produced the slides. Thanks a lot, Victoria. Thank you.
To Bernhard there, and for those wonderful slides. And as he said, it's a call to not just visit the booth outside, but for anybody joining us online, you can also see and connect with people online through various potential media and continue to think about the questions you want to ask in the future sessions this afternoon and over the coming days. Now, our next speaker is somebody you will have certainly got to know over the last couple of years. It's Kathryn Hadler, who is the director of ESRIC.
Moyen, and welcome to beautiful Luxembourg. We are absolutely astonished to see so many people attending this event, whether in person or online, so I welcome you on behalf of the organising committee. I'm the director of ESRIC. I have been here now for a year, but ESRIC itself is 2.5 years old. We were formed through a partnership between the European Space Agency, the Luxembourg Space Agency, and Luxembourg Institute of Science and Technology, of which we are a department and is our home. Now, when ESRIC was launched, it was launched with this vision, which you will have heard before. It has been mentioned in previous Space Resources Week. And the vision for ESRIC is that ESRIC will become the internationally recognized center of expertise for scientific, technical, business, and economic aspects related to the use of space resources for human and robotic space exploration, as well as for a future in-space economy. And that's still very much our vision for ESRIC. But what it doesn't do for you, the community, is tell you who exactly we are and what it is that we actually do. So I thought I would give you a little bit of detail about what we actually are doing at the moment and who we are. So ESRIC currently is 16 people. We are growing, but we are a team of 16. We have 2 masters interns as well at the moment. We comprise 12 nationalities, depending on how you count, but 12 nationalities, which I think is reflective of the diversity of people in Luxembourg in general. And we are 44% female, a number of which we are very proud. Now, you're sitting here today in Lux Expo. You are near to Luxembourg City. ESRIC itself is based down in Belval, in the southwest of the country. It's about 20 kilometers away, or half an hour on the train, which is free, from the main train station in the city. So Belval is where LIST is based. It's also where you can see the magnificent old refurbished blast furnaces. So it's down in iron ore country. And I think what's really interesting about this is that it really gives us a sense of our relationship with resources and the scale of engineering that is required to meet our need for resources. So I can very much recommend a visit there. In terms of our activities, we've already heard a little bit about what we do, but this is where our focus lies. So in terms of research, we have 11 researchers currently, of which 5 are PhD candidates. We have 14 active or planned research projects with numerous different industrial partners and also with different funding agencies, such as the Luxembourg National Funding Agency, the FNR. We have our commercialization pillar, and in here we have the now well-established startup support program and future plans, which we will hear more about in the coming days. In terms of our community and knowledge management support, you are here at Space Resources Week. This is one of our big activities, but also we hosted the ESA and ESRIC Challenge. We have also our knowledge sharing platform, which we will talk about shortly. So in a summary of our recent and our current and future activities. You will hear much more about them over the next 3 days. It is a packed schedule over the next 3 days. But these are the ESRIC-specific activities. We've heard a little about them already from Bernhard. In future, at ESRIC, we will host large research infrastructure, such as the Dusty Thermal Vacuum Chamber and the ground-based pilot plant. We will hear a lot about that in the coming days, but we'll hear more about it specifically this afternoon. In terms of our research projects, the demonstrators that we currently have a hydrogen reduction demonstrator. We will have molten salt electrolysis cells by the end of this year. And you can hear Dennis Harris talking more about our specific research projects or research activities later on this morning. There is an entire session devoted to commercialization and specifically the startup support program, and that is tomorrow afternoon, and further we will hear more about the further initiatives such as the Space Resources Accelerator. The challenge will be discussed this afternoon. The enormous challenge of the challenge will be discussed in addition to the announcement of the call for ideas. And you can find more about the knowledge sharing platform in the exhibition. So do visit and see the tangible table and give your feedback on what you, the community, require. But I was reflecting a little recently about where we have come as a community. It's almost exactly 5 years since that first European Space Resources workshop in ESTEC. It was July 2018. It was my first Space Resources event. It was super exciting. And we reflect a little on where we've come from 2018 to today, to 2023. The community has grown, but what becomes more evident and what will become evident over the next 3 days is the scale of the challenge. This is a huge and complex area. It covers many disciplines, many timescales, objectives, processes. And I said this last year at Space Resources Week, and I've said it many times over the last year. This is not something that can be achieved by one space agency, one company, one country alone. It requires a community. It requires us all. And that's very much the driving force behind the theme of this year, about synergies. How can we work together to make this become a reality? So I hope that you enjoy connecting with new contacts, catching up with old colleagues with this in mind. How can we work together to make this happen? But my final point is that in giving these opening speeches, there's not often opportunities for a graph. And as an academic at heart, I do like to present a graph. So I thought I would plot a graph. Here is my graph. And here we see the number of in-person participants as a function of the year. We'll not worry about the fact that it should be a bar chart. So here's my graph of number of participants versus year. And what we can conclude from this graph is that in future years, we are likely to need a bigger room. So with that in mind, I would like to thank you all for coming and participating, and I wish you a wonderful 3 days.
Thank you so much to Kathryn. And I'm quite sure in the next talk we might have 1 or 2 graphs that are a little bit more complicated. Our next speaker, for those who have been here year on year, you will know him very well. It's Jerry Sanders, lead for NASA's in-space resource utilization. And along with many other things, Jerry is known for his very, very busy presentations. So please give him a very warm welcome, strap in, and put your focus on.
Well, thank you very much. I want to thank Matthias and Kathryn and the organizing committee to allow me to come here today and talk to all of you. There we go. In the spirit of Minister Fayot, I'm here in this, to talk about cooperation and collaboration and future partnerships. So I'm going to give you an update on what NASA has been doing along those lines and where we are. A lot has happened since I was here last year giving a presentation on what we called our Envision Future Priorities. And I'll try to speed through some of these. To begin with, the vision is still the same, which is good. This is something that we looked, 20, 30, 40 years out. Where do we want to be with space resources? Give us that vision far in the future so that we can continue to work there. And so as we were talking last year, a big emphasis is commercial scale operations, sustainable commodities. These words were used on purpose to denote the fact that we are trying to think about creating industries and ecosystems and commercialization. As Bernhard's chart kind of mentioned, we're looking at the commodities, the oxygen, the water, the metals for construction, plant growth, and in particular, the transportation systems. One of the things to recognize is over time, NASA has basically a program for solicitations, both internal and external, starting from the left-hand side, the very low technology readiness level, the NASA innovation, advanced concepts, things that you write down on a napkin and say, hey, I got this great idea, all the way to the right-hand side, which is flying demonstrations, pilot plants, whatever the case may be. And our first Envision Future Priority strategic plan really covered basically the oxygen extraction from regolith pathway and the water mining pathway. Over the last year, we've received lots of inputs from internal and external through solicitations and conferences. We've expanded it to now include much more in the metal extraction aspects as well as the construction aspects. And in future iterations, we'll get into some of the waste processing, food plant growth. A big question mark is Mars ISRU. The past plan did not have Mars ISRU into it, but we are looking at when do we bring that into it, and maybe even moving it over to the left earlier. If you aren't aware of it, NASA released officially their Moon to Mars objectives at the IAC last year, and just within days, yesterday at the space conference in Colorado Springs, they've released updated versions of it. It's a great document if you haven't seen it. It basically covers all the objectives that NASA believes they are going to go towards with their Moon to Mars opportunities. I've broken those down into 3 primary areas of interest for ISRU: the resource assessment aspect, the ISRU usage aspect, and an area that is becoming more and more important, the responsible ISRU aspect. And again, it's an eye chart. You look at the charts afterwards. But what's interesting is those colors also denote where those objectives came from. Green is science objectives. Blue is transportation objectives. Purple is infrastructure objectives. And red is operational objectives. So ISRU influences and is influenced by all those different aspects in this ecosystem. The black arrows are the ones that we consider from an ISRU the most important that we should be following. And another interesting thing from the document is, irrespective of the objectives, NASA created what was called recurring tenets. These are things that no matter what you do, you should be working towards these tenets. And 6 out of the 9 of those tenets factor into ISRU: cooperation with industry, cooperation with international partners, interoperability, modularity, things that, standards and interfaces, things that are all very important to go forward. Another aspect that we are now looking on our next evolution has been, we focused last year on the polar region, particularly the oxygen from Highland regolith, as well as the polar volatiles. We're starting to think more globally long-term. So as we move away from the poles, what are the other resources that we would be interested in from a time and spatial evolutional aspect? The rare earth elements, the ilmenites, the pyroclastic glasses, and the solar wind volatiles. We try to start with the easiest resources to acquire with the minimum infrastructure, and we move from there. Another aspect that we've worked on over the last year is the role of industry, and how does government in general, whether it's European or US, really foster these kind of commercialization aspects that the previous speakers have mentioned. So you look at the graph is a standard mining operational type of aspect. And they break it down into several phases: the exploration phase, the development phase, the production phase, and eventually the remediation phase, which goes back to that responsible ISRU. The exploration phase does the reserve definition: where are the resources, how are they defined, as well as the technology demonstration aspects of, can I actually mine those resources and process them? Once you've laid that groundwork, then companies can go in and start developing the full-scale systems that eventually get to production phases. So if we impose some of the things that we've been talking about on this mining chart, you'll see, when we do our resource mapping, you've kind of moved the risk scale in the exploration phase over to slightly less risky. And if we put our pilot plant type of operations at the junction between exploration and development, then basically we've helped companies get through the worst negative cash flow areas that they exist in that exploration phase. So that's where really government should be supporting these activities. Oh, and one last point, if I can go backwards. And so I've highlighted, the fact that, again, if we think in the future, how do we do this with a circular economy and the responsible mining from the beginning? One of the changes that has happened two changes that have happened over the last year is, on the one hand, the timeline is slightly moving to the right because of budget issues. The second issue is we've decided to really focus primarily initially on our oxygen and metal extraction pathway versus the water pathway. And if you look at the chart, two of the CubeSats that we had assumed would help us find those polar resources basically are failed. While I'm a big fan of Viper, I helped create it to some extent early on with a project called Resolve. We're still questioning whether that alone will be enough to tell us where the water is and how to mine it. So there's that question mark going forward. We see ourselves working in collaboration with other countries as well as other areas such as our construction and our power areas. And now I'm showing on the right-hand side, as we're doing these demonstrations in pilot plant, again, our end goal is full-scale production from an ISRU implementation phase as well as from an operational and transportation phase. Again, eye charts. So one of the things that we've really done is taken the end-to-end flow diagram of looking for resources all the way to products, building that modularity, and we've written our gaps associated with each one of those that we have to close. And again, from a color perspective, you'll see multiple colors. They're not just ISRU gaps, they're excavation gaps, there's manufacturing gaps. So we're really trying to make sure everybody understands what those gaps are as a function of those different boxes. They're numbered. NASA will release the access to what we call Starport, which will show each one of these gaps so that companies can go in and say, oh, if a future solicitation is needed, these are the things and areas that we would want to work on. And I'm showing you two of them. We actually have 6 flow diagrams. The other thing we've done is we've plotted what are we currently working on? What's the starting and end TRL levels, and who is doing that? Is it government? Is it industry? Is it academia? Have those projects been completed? These snapshots are also used so that companies can look and say, well, who's spending money on these things? Maybe I partner with them. Or, hey, it's not getting to TRL 6, so obviously they're going to have a solicitation to go from wherever the end is to that next technology level. We're now also looking at how do we take what we do on the moon and go, use those same things on Mars. And the interesting thing is I love Venn diagrams. If you look at what you need to do for oxygen and metal extraction on the moon, if you look at what you need to do for water mining on the moon, and you look at what you need to do to make propellants, whether it's oxygen or methane or whatever the case on Mars, a good number of those technologies flow into the Mars program. And as Clive likes to say, it's moon and Mars, not moon to Mars. The other thing that's really interesting is when you start looking at production rates. You know, if I want to make 10 metric tons per year on the moon and I need to make 30 metric tons of propellant on Mars over a year and a half, the production rates are actually pretty similar. So you could see yourselves actually making modules that could go from one place to the other. And then lastly, we try to advertise what are our priorities. Make sure that if somebody's going to put money into it, if we're going to talk about partnerships, these are the things that get our attention the most. The first one is we need to start doing these demonstrations. We need to get onto the other planet, onto the moon, do those things that we've been talking about. Another is systems integration. And integration, as Kathryn pointed out, how do we build up these systems on Earth? How do we gain that experience before we set up mining operations or processing operations on the moon? As I mentioned, we are expanding our metal and aluminum extraction activities and our feedstocks for construction. We're looking at Mars. We are still obviously very interested in lunar polar volatiles and water in particular, but we really need to focus a lot more on finding those, mapping those, and Clive will talk very strongly about that, and I've been very supportive of his efforts. Another aspect is our close ties with life support, and what's not on this chart is we really do need to think about the circular economy and how to be responsible on the lunar surface as well. And with that, I will mention the new Envision Future Priorities has not necessarily been released, but it will show up at that website. Thank you very much.
Thank you so much, Jerry. It's always a pleasure to have you and your energy here in Luxembourg. And as was said this morning, all of the slides will be made available to digest in your own free time later. Now, our next speaker, it's with great pleasure, and it's been alluded to earlier today, to welcome to the stage Kyeong Ja Kim, who is from KIGAM's Space Resources Exploration and Utilization Center, the Korea Institute of Geoscience and Mineral Resources. So please give her a very warm welcome.
Good morning, everyone. I'm very honored to be here to present my work of KPRO GRS. So I also, very happy that Kathryn Hadler really mentioned about this opportunity. This is great pleasure for Korean, for Korean especially, yes. So the KPRO has launched the August 5 in 2022. Now, actually, it is on the moon at an altitude of 100 kilometers. But before it reached to the moon, 4.5 months, actually, it traveled for a long journey for scientific investigation, especially for KPRO gamma ray spectrometer, because the scientific objective for deep space is actually measuring gamma rays and the measuring background of gamma rays by the KGRS. So actually, I'm the PI of the KGRS, and I can introduce what is the KGRS. The KGRS is actually has the main detector as made of lanthanum bromide and shielding detector with a boron, 5% boron loaded plastic scintillator. And it is 6.3 kilogram. This is the lightest instrument so far ever been made. And we collect the data every 10 seconds. And the energy range, we actually cover the 30 kb X-ray region and up to 12 MeV gamma ray region. We get two signals, high gain and low gain. And so that we can actually measure gamma ray, neutron, and X-rays on the moon. And we are expect that, at least 10 elemental composition we can study on the moon. And as a objective, scientific objective, we'll do gamma ray and neutron and X-ray on the moon. And geology, studying geology and resources is very important with this kind of instrument. So gamma ray bursts and solar activities also I will mention about what we have been done. So I'm sure many of you know already that GRB 221009 that actually detected by KPRO-GRS. We are so excited about that. And it is known to be the strongest GRB ever measured. And recently NASA mentioned that it is 1 in 10,000 years. The location is the Sagittarius constellation, and distance is about 2.4 light years. And it is known to be a dying massive star or the birth of the black hole. And it is 1.9 billion light years. So I was so happy that so far away it happened, and then it traveled so many years. And then in the case of KGRS, we also not near the Earth. Actually, it was a far distance, at least 1.5 million kilometers. The farthest distance KPRO could be was 1.55 million kilometers. I couldn't sleep for many days for this kind of measurement. So it's like I got gift from God from the space. So I feel like I belong to the space. So I was so happy. And so data is very good. So we actually measured this we actually had the gamma ray, the channels. And then we also used the three bins for total count from the detector itself. I think it is important to follow what the management said, what to do. Actually, at the beginning, the KPRO was supposed to go to the moon directly, not going many months for deep space investigation. And then I was asked to do some scientific study to be done. So that's why later stage, actually, I made the gamma ray channels. So yeah, I think the level of increase of gamma rays, actually, we have 8 channels, and the highest one is about 98 times higher from the ground level. And it is actually 50% of the dead time. So if we multiply that, it's much higher. So this is what you can see, the image of the gamma ray burst, GRB 221009A, and this is the image. And this is the gamma ray spectrum by KGRS. So the bottom part is the intrinsic gamma ray spectrum by lanthanum bromide. And the top one is the red one is the first arrive of the gamma ray burst. And then you can see about 100 times, right? And the second one, the blue ones, is about 10 times the small bursts actually arrived. So this is very good measurement. This is very unique. And this has been measured from not near the Earth, but it is in deep space. So this is historical for Korean to do this kind of science. And when you compare with this our data, so we have 8 energy bins. So mostly X-ray region and then gamma ray regions. And then you can see in 7 minutes what happened is very clearly recorded. And we are well compared with this, the NASA's data. And you can see that how this was strong, right, compared to previous gamma ray bursts. So, always we have to try to compare whether our data is right or not, based upon what other references out there. So you can see 2 channels, the data, A and then B was radio signal, and then NASA film data. And then there's ESA. I was surprised that ESA does a lot of this kind of research in gamma ray burst, and there's 4 data available. And think about how our data is good. So I was so excited about this. And my one of objective for measuring gamma ray burst for the KGRS has accomplished. I'm so happy for that. And so I thought about, okay, so that was the strongest gamma ray in our measurement history. Then how strong, how is dangerous? However, we know that the Earth's ionosphere perturbed by this gamma ray burst, but we were safe, right? And this is a well matched with radio signal. If we think about whether gamma ray burst is going to be much stronger, in the case, we can see the example 440 million years ago, about 2/3 of all species has extincted, right? So we are happy that we don't have this kind of situation, but we cannot predict gamma ray burst, but we can only measure right away, instantly we can measure. So that's we can continue this kind of study. Another thing, I mean, I feel like GRS has so many outcomes, scientific results. So many of you know already about the sun's activity is very strong nowadays. Because why? Because it is solar cycle 25 and 2025. It is not reached to the solar maximum, but it is on heel of the solar maximum. So we see a lot of activities. And the most of our measurement actually, it was the X-rays and gamma ray, that comes out, and we actually measured. But there's a very interesting thing came out. That was for coronal mass ejection. In that case, actually, proton just came to lunar surface, and then I saw neutrons. So it's so exciting. So how the gamma ray is produced? Actually, proton as a primary particles actually arrive to the lunar surface, and then secondly, neutrons actually produced, and then neutrons interact with the element on the surface of the moon, and then gamma ray or X-rays actually produced. We observed that part, and we're going to publish that very soon. So we measure the gamma ray burst and gamma ray, not only gamma ray burst and the solar activities with this instrument. So another main thing, the main thing was that we want to measure, the gamma ray that is related to elemental compositions. So when we compare Chang'e data, Chang'e 2 has the same sensor, so lanthanum bromide, but Chang'e had only about 6 months of data collection. Our case, actually, we had about 3 months already, but nominal mission is 2023, and we're going to have extended 2 years of data because NASA wanted to continue shadow cam operation. So luckily, we're going to get the possibility that up to 2 more years of data will be collected. So we're going to have more than 3 years of the data collection compared to previous mission. So we are hoping that our aim for lunar geology and lunar resources prospecting could be possible, and then also radiation monitoring, gamma ray and neutron and X-rays are also possible. And then on the moon, we also can study space weathering and gamma ray burst as well. So a lot of things can be done with a small GRS instrument. So this is the last slide I want to show. So our future work will be finding water and volatiles. So over 3 years of the data collection, we may be able to do all of this, the aim scientific objectives. You can see the global map of the green one is actually silicon, and the other one is actually helium-3 map. And this kind of maps we can study for geology as well as the resource map. So these maps were based on Kaguya data, Kaguya GRS data, and lunar prospector, and then Chandrian's MQ. This kind of study will be done with KGRS of 3 more years of data collection. And definitely, I hope we can be able to do more the detection, for example, water or volatiles. And this can be good contribution for future for resource assessment and possibly landing site candidate studies. So that's what I'm hoping for. So next time, I hope I can come with new data with you. Thank you.
Thank you so much to Kyeong Ja Kim there for that inspiring talk and a reflection of why people do science. And hopefully she can be here next year with some wonderful results, just like she's shown us today, and some lovely pictures to look at as well from deep space. Our next speaker, all of you will know who he is. It is, of course, Matthias Maurer, who is an astronaut with ESA.
Good morning, everyone. It's a great honor to be back here. Many thanks to Matthias Lenk and the Luxembourg Space Agency for inviting me. As Mr. Fayot said this morning, I'm coming from right across the border, and therefore in my heart there's also a big piece for Luxembourg in there. So I feel like German, Luxembourg combined. Last year I couldn't attend here. I was in space, so good excuse. And I tell you a secret, looking down from space to Earth, I couldn't see a border between Luxembourg and Germany. So I couldn't see any other borders at all. And the big messages that we as humans up there in space want to convey first is exploration is a human endeavor, human curiosity that we all should do on our common path. On the ISS, we do a lot of research that is linked also to exploration. And once we fly to the moon, fly to Mars, the human will be in the loop. And here you see 3 photos that should recall you a little bit when you develop your systems, that you also think of the human in the loop. As a human, we have to do a spacewalk on the moon, on Mars. And everything that you design, we are good consumers of your oxygen, of your water, but we also need to have special tools, because in such a spacesuit, working is not like working here on planet Earth. In the middle, you see me floating in a Columbus module, and I look a little bit different. It's because in gravity, in zero gravity, the human body changes, it adapts. So in zero gravity, we have chicken legs and a puffy face, so a fluid shift, and lots of other things that go on in the human body. On the moon, we have gravity, only a bit. On the Mars, we have more. So still there, we believe the human body will adapt, and so also this needs to be taken into account. But we also do research. In the middle photo, I showed an example. It's material research. What I also did is, for example, I mixed concrete using regolith. I don't believe we will build really a house on the moon using the same classical methods as using concrete, making here on Earth, on the moon, but it is an option, and it's an option that resulted in very good specimens. On the left, you see a photo where I interact with a kind of a rover. It's a bumblebee, it's called. It's a flying vehicle, and that is what we expect on the moon and Mars as well. Always an interaction between the human and a machine. So it is never the machine alone, it's never the human alone. The future will be the cooperation of both. Last year was very successful with the first Artemis 1 launch. In this Artemis 1 launch, there was not a human, but there were some sensors in there installed on human dummies, and these sensors measured the radiation field around the moon. Roughly, you can say like 6 months on the ISS equivalence to 1 month on the moon as a radiation dose, what we humans get. And I was especially interested also listening to the talk of our Korean colleagues before, like all this radiation environment on the moon. It is also very important like for us humans that want to fly to the moon, to consider what doses can we expect, what impact on the human body, and especially flying later on to Mars. I mean, a mission to Mars will be something of almost 2 years. 2 years, at the current methods, it would exceed the radiation dose I am allowed as an astronaut to take. It's roughly, you can say, like if my risk to get cancer increases by 3%, it's the end of my career. I believe the mission to Mars, it goes way beyond still. So we need to find solutions for that. I'm also very happy for my 4 friends that were named for the Artemis 2 mission. They will pave the way for bringing humans back to the moon. And I'm especially proud to have contributed a little bit to the Artemis 2 mission. So Artemis 2, they will not land on the moon, they will fly around, they will check out the entire system. And one of the most important systems on board is the life support system. And there's also a toilet. And the toilet may fail. And so my contribution was to test the procedure. What do you do if the toilet fails? I leave it with the mystery. So the Korean colleagues just mentioned the Danuri mission. On the Danuri mission, we also have the shadow cam. It's the NASA cam that was provided, and it allows to look deep into the craters to bring light into where there is no light. And that's the place where I would like to go as an astronaut, to go into the deep craters and to find the water ice on the moon. We also have the mission of the iSpace that will land, and it's a Japanese mission, but I believe also there's an office here in Luxembourg. So it's also a piece of Europe, then in this case, flying to the moon, crossing our fingers that the mission will land successfully next week is the attempt. And we also have exciting times on Mars, where samples were already cached for a later pickup by a small helicopter. Yeah, I guess we were all crossing fingers on Monday for the successful launch of the new Starship. Hopefully it will launch tomorrow. Once it launches, it might be a real game changer, like 100, 150 tons to low Earth orbit. If you don't recycle the rocket, what we hopefully do, it's up to 250 tons flying to space. So that will be a new way to bring new structures to space. We can fly stuff that was not feasible before. And I truly believe it will be, we were entering a new era in human and in spaceflight in general. So I absolutely cross my fingers that SpaceX will make this happen, that we will fly the Starship. We will also use it as the lander in the middle, and also the entire space infrastructure, using it as a tanker to refuel stuff in space. Very, very exciting. The technology exploration architecture. We heard already some talks this morning. I just want to focus on the term in the middle, the in situ resource utilization, which is the focus of you guys coming here and making everything possible. It is the key for a sustainable exploration. So we astronauts, we love flight to space, but we all understand the mission is not flying just to the moon to plant a flag, or flying to Mars just to plant a flag. We want to do it sustainably. We want to build a house on the moon, which is a little bit like having a research station in Antarctica, and we want to stay there. And this is only possible if you help us to make this sustainable by enabling us with your processes. Exploration made in Europe. So we saw the Argonaut mentioned by Bernhard Hufenbach this morning, also the Moonlight project. But talking a little bit of the humans in the loop, there are all these pictures down here. My colleague Jürgen Schlutz will tomorrow introduce the Lunar Facility. It's a training and technology development facility in Cologne. It's at the European Astronaut Center. It will be built this year, hopefully being ready by the end of February next year, then ready for outfitting. So by the end of 24, we will hopefully start training astronauts there and bring in also scientists. It's open, it's free to use. Student teams, everybody who has an equipment that he or she wants to test in a lunar environment is kindly invited to join us in Cologne. We will have gravity offloading, we will have conditions as on the moon with the moonlight, like the very intense spotlight. We will have 1,000 tons of regolith in there. We will have a dust lab. We will have lots of other fancy stuff. And in there, we want to do everything from the moment when the Eagle has landed, or whatever the name will be of the next spacecraft, 5 days on the surface of the moon. We can everything play there. Hopefully also bringing NASA astronauts over there, because it will be most probably one of the best facilities in the world for testing exploration in an integrated way. So please keep this on your radar and feel kindly invited to come. And that's already all. Thank you very much, and have a successful week.